Okay. Today we're going to focus on distance. What do I mean by that?
The distance from one point to another, like in millimeters.
The path integral of the metric multiplied by this thing. What column is that?
Okay, so if I have 2 points, I want to know the length of the segment between 2 points. Whether there is a segment there or not, if we have 2 points, how long is the segment that is there or that would be there? Colin?
How do you define length?
How would you define it?
I use the metric tensor for Euclidean space.
Where's that?
The metric tensor basically tells you how to measure distances in any Riemannian or Lorentzian space. It's used in general relativity, for example, to describe the curvature of space-time.
Or like
So what's the
Albert
demo
Einstein.
rate?
So, we're just going to be pretty simple, okay?
Accelerate my ruler to 90% the speed of light.
Okay, so if I wanted to know the distance between C and F, if I were to draw that segment, how long would it be?
6.
What's a good way of being able to just, how could I like solve that?
Bunny hop.
You show the bunny hops.
The absolute value of the difference.
Ah, the absolute value of the difference.
Technically, this is assuming that we're using a coordinate system matched up with the units we're using for distance, which we probably are. But
We
it's also-
probably are, Colin.
It's also assuming it's
We
not
probably are,
We have to
Colin.
write that out. The easy way.
What's the easy way?
Just like yeah, like -5, -1.
But what if I gave you like
3.
2 ridiculous numbers? You need to be able to know to do that.
Yeah, calculator.
There's a calculator to do the math.
I know, but you have to be able to know what to type in the calculator, people.
If it's an algorithm, would be extremely slow for a
Yes.
Are we counting 0 as a point or no?
Yes.
And whether it be 7 or 2?
So if I start here and end here, 1, 2, 3, 4, 5, 6.
It got smaller and
It's 7
smaller.
points.
Yeah, I did the shoot.
Okay.
But,
Like 6, yeah.
yeah. Okay, how about A to
Also
D?
6.
Is it? Is it 6? Because we would take the absolute value of 2 minus -4.
Which is 6.
Thank you.
How do you make your boxes so perfect?
Because she has the
Because my iPad helps me out.
Notability. If you just
Watch.
hold the thing
I can make a circle.
and then just hold it down.
Boom.
Oh,
You're not gonna bet the graphics.
You should go do that on the perfect circle.
Okay. Hudson, what is the distance between C and E?
The absolute value of -3 minus -1.
Which is?
Is that
Well, how come the 3's coming first?
I start with right minus left.
Because
But-
because we're using absolute value, we're subtracting.
So we're using absolute value because if you did -1 minus 3, like if you went the other way, because you could say -1 minus 3, which is fine, but that's a negative number, and distance is always going to be positive. So it doesn't matter which one you start with.
Wait, but doesn't it give the same answer anyways?
Right, as long as you use the absolute value.
Oh.
Yeah. Which is why we're using the absolute value. Okay. have a conversation at your table and determine if CB and DF are congruent.
They are, they're all quite wrong.
Jeez.
C to B,
No.
D to F.
You did not want to space this out like one.
Because I counted 2 in between, there's only 1 in between, so it's a bigger one.
Technically, I counted one.
Okay. Matson, what is the measure of CB? Notice how there's no hat on CB if I'm talking about the measure. Emma, what's the measure of DF? Okay, so since the measures are not the same, CB, the segment, and DF, the segment, are in fact not congruent.
That's not what the paper that they're on. They could include lengths that go through 3D space they're congruent.
We are working on 2D, buddy. 2D.
Technically, it doesn't specify.
Technically, Colin.
Oh, Colin.
Yay, we finally got another.
Is this what you're aiming for? Maybe we should aim to go down. Let's trend down.
Carl has to push us every time.
Okay. Q and R are -7 and 12. The coordinates of S and T are -3 and 16. I want to know if these two are segments are congruent.
Yes. C. There.
Oh, there's no C.
No, what C is yes in Spanish.
I know, Colin. Okay.
Oh, man.
I can, you can. Okay, so QR, if we talk about that distance, is what?
It's 19.
Okay. And if we talk about ST, okay. So we can write that QR, the segment, is congruent to ST, the segment. So again, I'm going to emphasize when we're talking about measure of a segment, there's no segment hat. When we're talking about the segments without the numeric values, we put the hat on there.
Why would we put congruent when they're the same thing? Can we just put equal?
He's talking about measure.
So the measurements are equal, the segments are congruent. That's how those are read.
Okay, that's what it says.
Okay. Let me say it again. The measurements are equal. The segments are congruent. All right, turn the page. Okay. So I have line segment PQ, right? And I want to find the distance between P and Q. So this red segment here, I want to find that length. Okay? Now, that is a D.
Oh,
Told
it is?
you.
Oh, distance. Oh, not length. Okay.
Okay, so what can I make with this line segment since it's at a slant?
Oh, right triangle.
I knew you would know the answer to that question. I can make a right triangle.
How did
No?
you instantly know that?
Because I programmed this.
I'm going to call this distance A and this distance B.
Oh, the.
Let's see.
They were wrong.
H squared
Pythagorean theorem is what just came out of your mouth. I know it. And what is it?
A squared plus B squared equals C squared.
But where's there's no C?
Whereas D squared.
A distance.
D squared.
But we're going to use D for distance. Okay, write it down. Now, since we're in the coordinate plane, we have two dimensions, okay? So, this coordinate right here, P, is at the coordinate x1, y1. And this coordinate Q is at the coordinate x2, y2.
Why is it a double comma in between X and Y? Does that mean anything?
That is not a double comma. Here's the deal. It's a 1. This is a, we call this a subscript. Okay, so this is an XY coordinate, but I gave it a subscript of 1 because it's our first coordinate.
Let's do the indexing.
And then here, we have an XY coordinate, but it's our second one. So I put a subscript of 2. Okay? Bless you. Now, I called this distance A, but really it's the horizontal distance between the two coordinates. Do you see what I'm saying?
Not really.
I start at x1 and I end at x2.
So which one? I thought the one above it was X2.
Yeah. But I'm not moving my y's yet.
So is 1.
So like this is x1
Oh.
and this is x2.
Okay, yeah, that makes sense.
So if I subtract them,
Then you get.
then that's A.
Oh, I remember this kind of.
I think you will. And then what about this right here?
B.
B is just the distance between
X squared
the
minus
y's because it's our
So
verticals.
is it A2 over x2 minus x1?
No, I replaced A because it's A squared. And if I want just D for distance, not D squared for distance squared, how do I undo a square?
You root it.
Root it.
There's positive
Root
y.
it. Don't root it.
Okay, so our distance formula, D for distance, is the square root of x2 minus x1 squared plus y2 minus y1 squared.
Wait, so 1, 2,
The subscript or the square?
the square.
Because of the Pythagorean theorem.
But doesn't it get removed once we start solving it?
No. Because
No, this one gets removed. These cancel out. But since we have addition, Hudson, we can't cancel out the square and square root. Cash, what do you need, bud?
I need a Band-Aid.
I'm gonna let you try that again.
Can I get a Band-Aid?
Yes. So come here, bud. In here, pick the one that you want.
Wait, are we
kind of math is
doing
used in
the-
Fortnite. Well, actually, I don't know. I've never played Fortnite, but it's probably used in Fortnite to determine distances and they get. He's talking about Fortnite. You play Fortnite. You put a 3 on the board. Are you
What did you just say?
Are there ones with cars?
No.
Dude, just get a band.
He's actually is.
Okay. So let me show you how to use this formula. Raise your hand if you remember using this formula.
Kind of.
I used it in Rapid Simulator.
Like, did you use it in algebra?
Yeah. Yeah, we did.
Okay, we
did the
we did the Pythagorean theorem. We did not do this.
I agree with that. Okay.
Can you find that logo?
No. Okay, so this is new to you. Okay. So here I have A and B. I want to find the distance between A and B. Okay? So our distance is, go ahead and draw a giant square root sign. I will tell you right now, it doesn't matter which one you pick to be x1, y1 versus x2, y2. Okay? But I'm just going to go with the order in which they've been given to me. So, I need x2.
7. Wait.
I would put 3 minus x1. Oh, whoops. x1. X1 is negative 2.
Yeah.
Okay. So we have 3 minus negative 2. Okay. You can do that. I will do it soon. Then we have y2 minus y1. What?
Where did you get 4?
No, I'll
Go get 5 and 7.
Okay, look at this.
It does something similar.
So this is x1, y1. This is x2, y2.
Because it's X.
Okay. The lights went on there for you. Okay. So this becomes 5 squared, which is?
25.
25.
That's what he said. Okay. Plus this becomes 2 squared, which is?
4.
So the distance between the two coordinates is 29.
And the square root of that is a.
Doesn't matter. Leave it.
Wait, why don't you just like
Nope.
6 by 4? Simplify it back down.
Simplify it to what?
Like 5 and 2. Back down.
We cannot do that. This is not 7.
But the one above it is.
No, it's not.
So the difference.
Because the square root of 49 is 7. So we can do this, Gage. We can do 49 times 36, and that's the same as 7 times 6. Okay? But if we have 49 plus 36, we cannot separate out the square root. We have to do the addition underneath of it. Okay? Okay. Now, since the distance between A and B is the square root of 29, then we can say that the measure of AB is the square root of 29. What?
Oh, shoot. 7 minus 5. Oh, this is level.
No. No, this is...
Oh, wait. No, never mind.
Okay, so the reason why I pointed that out is because, look at example 5. I want you to find me the segment length JK. But for real, that's like magic. So if I'm asking for the segment length, I'm really just asking for the distance. Okay, so here again, we are going to use the distance formula. Okay.
It's just 12.
What?
Just hold on. What is x2?
2.
Minus x1.
Is there a song with this one?
Nope.
Just remember.
Okay. What about y2?
9 plus 3.
9 minus negative 3. Thank you, Gage. Okay. So 2 minus 4 squared really just becomes 4. 9 minus negative 3 squared really just becomes 144. So the distance between J and K, the measure of segment JK, is the square root of 148.
You can simplify that.
We are not going to, because we'll worry about that next semester. Okay?
Why? Yeah, that's long.
Okay, so from your book, You can either go to the online book or grab one from the shelf. From section 1-4, we're gonna do 1 through 6, 13 to 20, 24 to 27, and 30. We have 10 minutes. Let's get